thanks to 3dprint.com. So today we have some news. Well, first it comes us a little bit via Hackaday, and Hackaday has an article on 3D print your own Seiko style magic lever energy harvester. And this is based on a video by a lovely gentleman called Robert Murray Smith, who is essentially showing this kind of one-way ratcheting kind of gear system, which is based upon Seiko and a bunch of other companies as well. But this is based upon a Seiko kind of mechanical watch component. Basically, all mechanical watches are wound by the movement of your hand, and they harvest energy in a mechanical way. It's, of course, a wondrous thing, really, if you think about it. You have something that's mechanical, there's no electronics in it, and just based upon your movement, that thing can theoretically run for a very, very long time. These kind of things, in this case, he 3D printed it. First off, what a wonderful demonstration of showing you how this mechanism works, right? But also, what the point they make at Hackaday is a really valid one. Is like, hey, you could make an energy harvesting device in this way. Maybe if you could put this on a bicycle or another vehicle or something like that, it could actually be used to harvest energy. And this point has to do a little bit with the point I tried to make earlier on this series, is macro MEMS, right? I mean, MEMS are small devices that take a lot of effort to get them made. Initially, the startup costs are quite high, but once we make a lot of these accelerometers or other sensors, we can make these tiny, really self-contained, really, really fantastically versatile things that make sure that our phone knows how many paces we took today and that kind of thing. But the thing is, the spin-up cost, or the cost for one production run is quite high. So millions of iPhones totally makes sense. But what if you wanted a tire sensor for a fire truck? Right, where you need to make a particular tire sensor to warn you of the fire truck because it's really particularly dangerous, and you just don't have the ability to use these MEMS products. Now, theoretically, imagine you made a 3D printed kind of MEMS sensor, a sensor that would monitor this tire pressure. It's much too clunky. It's really huge. There's some design costs involved, but the thing itself would be quite cheap. All right. Now, in that case, this could really make sense, this macro MEMS idea. And I love that the Hackaday is also thinking about systems like this of people printing energy harvesting devices and mechanical energy harvesting. I think that's a wonderful thing to be doing. So I hope more people will do that. Another thing is a Ukrainian entrepreneur, Ihor Yefimenko, I think, has made demining boots. So this, him and his company have made mine clearing boots that are meant to be resistant to mine and help protect the wearer against mine explosions. And they say that they're cheaper than secondhand mining boots that are imported from other countries. They just use regular desktop 3D printers to make them. And this is another kind of example of improvisation of using 3D printers in austere environments to have a kind of a duct tape solution to a problem. Like, you don't have mining boots, they're too expensive, let's make them here. And normally you wouldn't do this. Normally you'd take to other production methods, but here in this kind of exigent circumstances, 3D printing is a solution. And I think that this is another example of this. We're seeing this as well in Ukraine for munitions. We're seeing this drone. We're seeing this for drone components. We're seeing this for sea drones. We're seeing 3D printing. This is really the 3D printing war, as in this is the war where 3D printing is all of a sudden going to be top of mind of any kind of procurement, special operations, quartermaster type person, and any kind of like leader of a country is really going to realize that the 3D printing is something that they can use to duct tape a lot of problems as they come up. And this is another example of this, albeit a much more benign one, albeit a much more kind of nicer one, and the one that could have a bigger market elsewhere, because there's lots of other countries where there are many mines everywhere, and there's lots of people who are doing demining work without the necessary protection. So low-cost 3D printed demining boots could very well be a very viable product going later. It was good to see this kind of innovation happening, also in a non-lethal, non-kinetic kind of way. The next thing is from Specialized. Specialized has a new mirror tech kind of 3D printed finish, where at specific points of the saddle, they produce a different design where the stress is the greatest. And what's more, this saddle behaves more or less normally on like a flat road for your bicycle. And at the moment where you're going on some kind of Paris-Roubaix kind of like really very rough road, it actually will protect you much more compared to just a regular foam kind of a thing. So this is similar to what we've seen in the NFL helmets, where we're designing structures to perform in one way for very, very fast, hard impacts, and the other way to very, very heavy, slow impacts. It's the same thing using 3D printing to really absorb the right situations, or the ones that cause the greatest pain or harm to the person. The saddle itself uses about 22,000 struts and 10,000 nodes. It's plastered on top of a carbon rail, and it's made by EPU. I like the fact that this is not purely looking at this kind of like, oh, look, it's a 3D printed saddle. They're really designing a more functional kind of space here. And of course, the fact that it's EPU means that it's probably another victory for Carbon 3D. Carbon is doing a lot in saddles and has done a lot to make this space a lot more open, and is producing these either directly or indirectly through partners for a lot of these companies. So great business development job for them. The company says that it has 26% pressure reduction, whatever that means, compared to other saddles. And this is also really nice. So they have different saddle widths, right? They've got this retool data thing. And they have this idea of this body geometry methodology. So the idea behind that is that you can customize the saddle width at least to your body, right? Great idea. Now, do they come up with some kind of really contrived scanning thing? There's a happy butt scanning solution where you sit in a kind of like a foam and then you scan that later on, done by another company. No. Actually, what Specialized has come up with is a pretty simple way to do this using a little online tool of theirs and a marker and some cardboard. So I like this because we always in 3D printing will say, oh, we need to mass customize something. How do we 3D scan it, right? That's the thing that we always look at. But in this case, well, maybe it'd be a good idea to just use cardboard and a marker, right? And I think that's a really, really good idea. Now, this is good news because Specialized is doing this. Celicel Marco is doing this. Physic, Joyseat, Bjorn Cycles. Tons of people are making these seats. What's more, they cost $300 to $400. So we know they're making money. We know the pricing of these things, right? So we know they're making money on this stuff. So this is a huge opportunity. There's a lot of money no object cycle buyers out there. The bicycles, the top end bicycles used to be $5,000, which is an insane amount of money, but now they're $10,000 or $20,000, right? So it's a really money no object market where people really appreciate lightweight, where people really appreciate comfort. Cooling is a really, really big thing that 3D printing can bring as well. And responding to different impacts like this mirror technology thing by Specialized does is, of course, another wonderful thing. So I think this is a great sign forward. I think bicycles is a huge market for us potentially, and cycle and Carbon's doing a great job here. Really, really great at opening up this market for themselves at least, and perhaps in the future other people as well. The last thing is a Swiss startup. It's called Seiki Robotics, and it's SAEKI, which got a 2.3 million seed round about combining robotics with 3D printing. So what they want to do is create a production cell, an enclosed production cell that combines polymer printing with machining and inspection in one cell. So kind of similar to like what a lot of people are doing, kind of similar to what a bunch of companies have been doing for a long time with DED and stuff like that, and having these automated production cells. It's kind of a no-touch type of environment, fully automated. What the company wants to do, they have a bunch of different go-to-market ideas going forward, but they really, really hope to first work on formwork. So they want to 3D print polymer, machine it down, then inspect it, and out comes a polymer formwork part that then can be used as a mold for concrete structures and complex concrete structures for houses, or also for very technical type of constructions. And the formwork is a huge opportunity for 3D printing. We talk more about 3D printing houses and directly 3D printing, but formwork itself is great. They hope to come up with a way to then recycle that formwork, which of course is very environmentally friendly compared to the alternative, usually there's wood that's thrown away. So that can be a really, really advantageous thing. They also hope to rent out the robots. So they don't want to sell them, but they want people to rent them out for a certain time period, just like a lot of construction equipment is rented out right now. And later on, they hope to move into a lot of other markets. I think it's great. I think it's a wonderful startup, very timely, very good idea. I'm not sure what the actual technology is. I'm not sure what Seiki's actually doing that can make this better than other people, but sometimes a good go-to-market and a good idea is enough. Anyway, so thank you very much. And thank you for listening. This is another edition of 3D Printing News Unpeeled. And my name is Joris Peels. Have a great day.